class. It may have errors, but it's still powerful. I'm going to explain you. I'm going to show you how powerful it is. But before that, I'm going to introduce myself. This is my picture. This is me in 2017, not now. And okay, my name is Aditya Kresna, but the correct pronunciation is Aditya Kresna. My first nickname is Aditya, but this is so redundant. I mean, has collision, if you know what I mean. And because we have Aditya Susena too, yeah. And second nickname is Kresna. This is most people call me this. And the last nickname is Ujang 360. This is has collision free.
Yeah, hash collision free.
Yeah. And my job title is apparently Chief Research and Development in Bitwyre.
That's good.
So I do a lot of research and
Amazing
development.
things. Very, very amazing things.
Yeah, thank you. But yeah, superlative from Dendi. Okay, and my LinkedIn path is, as you can see, you can just add me or just look at it. Whatever. I do low-level coding. I do high-level coding in Rust, C, C#, but not C++. Not yet, maybe. Songking laughing. Songking is going to teach me about C++. But what I don't do is user interface. I don't like it, and I cannot do it. Just and Songking, you can do user interface, right?
Not really.
You're lying, man. Okay. So I'm going to start with 5 Rust buzzwords. Number 1 is Rust is zero-cost abstraction. So in object-oriented programming, there are things we call object and inheritance. But the problem is with deep inheritance is it is costly. So it's kind of problematic with if the performance is a feature. So Rust gives you, number 1, zero-cost abstraction. And the second one is memory safety. I cannot do wrong in Rust. So in the first month with my personal journey with Rust, the learning curve is very steep, but what I learned from that 1 month is Rust is very safe. You can't do wrong with memory safety in Rust. The third one is fearless concurrency. I will show you how fearless I was while implementing a WebSocket code in Rust. But and the fourth one is friendly neighbor compiler. This means the Rust compiler is very friendly. If there is an error of compile time error, the compiler will tell you which error and explain to you why it should be an error, and ultimately it will give you advice how to do the correct one. This is amazing. And the fifth one, last one, is Rust is fast, kind of hard, but not that hard. I will show you. And the next one is the challenges. This is Rust 5 challenges I've been having in these last 2 months. The ownership and lifetime concept. This is the very problematic if you don't usually code in the right one. I mean, correctness is important, right? And Rust compiler enforces you to do the right thing with object lifetime, object ownership, who's owning that object, who's owning that struct, etc. And the second one, I mentioned friendly neighbor compiler, and the compiler is very noisy. I mean, sometimes you want to do an easy thing like passing reference and modify it, but the compiler gives you a lot of warning and a lot of suggestion. But apparently in the last 2 months, I made peace with it, amid peace, and now I'm fluent. So it took me only 2 months. And the third one is what I'm having now is dependence nightmare. But good thing is Rust have cargo, um, which uh, Rust have crates. It's like library in other languages, and in C Sharp it's like NuGet. It's easy, and in C++, Songkeng mentioned Conan, right?
Yes. Yeah.
Yeah, apparently we have that in Rust also. Cargo, the name. So, and the fourth one is the build binary size. It's quite big, so it's kind of hard to build a small code. You know, I 3 days ago I tried to build a small code with Rust to fit the L1 cache, which is very small. It's only 64 kilobytes. But I failed. But yeah, I will show you later. And the last one is minimum unsafe code. This is the challenge of having good performance of Rust code. Sometimes you have to do some unsafe code in order to do so. And the next one, this is my example prototypes, Bitwyre example prototypes in Rust. The first one is the WebSocket core. This is the GitHub path, WebSocket core. And what I've mentioned earlier, this is a powerful prototyping. I made this WebSocket core out of nothing in 9 days, which is, I think it's not bad. And this code is public, so you can see it in our GitHub repository. So I will not show you today. And the next one is the matching engine. This is the GitHub path. I made it in 3 days, and apparently it's not public.
That's pretty amazing. Yeah, that's pretty amazing. Yeah.
3 days.
Yeah.
2 months learning curve, and because this code is not public, so I will show you today. Okay, this is the WebSocket core. I'm not going to show the code. This is the performance of WebSocket core, and I can beat Alex's performance somehow.
That's amazing. I can't wait to see like Alex's reaction seeing this graph. You know, like I like when he's not here. Exactly. Too bad he's not here. I can imagine.
I think Alex will get mad and
Actually, where is yours, Krishna? I'm not seeing WebSocket somewhere. Where is yours?
Sorry.
I mean, where is yours? I'm just seeing
his one
Alex.
is Alex's. He's in the middle, I think, right?
Oh yeah.
Yours is in the middle. Async client.
Mine is async client and sync client. These two.
Well,
technically,
yeah. Alex WebSocket is Alex reference only that. The other thing is mine. And then. So I forgot to mention that WebSocket core has 3 features, which is reactive WebSocket, which client sends a message, sends a query, and then the server responds it, and this is the result. And the next one is pops up broadcast, which is quite fast, and I did not find Alex's implementation, but this is mine with 60 and 96 clients. It can achieve 1,200,000 messages per second. But apparently, if one client only 16,000, this is because the concurrency model I'm using. The concurrency model is actor concurrency model. I think some of us know about it. Have you read about it, Sanki? Never mind.
About
actor framework.
Yeah, I actually have.
Yes.
Yeah. Actually have it. Could you like explain just a little bit, or do you think like that might be?
So actor framework. well, I can explain you a little about
Sure.
it. And so in concurrency, there are so many models, like preemptive multitasking, which is only in embedded system, and then cooperative multi-threading. Cooperative multi-threading is kind of hard and not good for our case, because we have so many clients, and this service must be scale up. I mean, has to be very fast when the user is so many. And then the last one, which is not the last one of all the models in the world, but the last one I've been exploring to use is the work stealing multitasking, work stealing multi-threading. It's actually Erlang multi-threading model.
Okay.
Yeah, and yeah, you can read about it later.
I'll look it up. That's thank you. That's
not so good for one thread. Only 60,000 messages. Yeah.
Okay. So for the our audience right now, maybe several of you guys have not or have any technical expertise, but yeah. I hope if anyone just has questions, don't hesitate to directly ask, right?
Yeah.
So, yeah.
That's true. Just ask. Okay. And the last one for this WebSocket is the periodic message, which is quite challenging actually, because we need to actually keep 16 hertz monotonic message for client. This is useful for time synchronization and pretty much anything periodic. Yeah, I mean like ticker. If we decided to do batching ticker, this is the hardest part actually.
Right. Maybe if someone's not from the financial industry, a ticker might not be something that he or she understand. Maybe.
Okay.
Hi Nanan, how's it going? We have just been started for around 5 minutes. Kresna has started his presentation, so he's explaining about his WebSocket results and
a little bit, just a little bit.
So imagine someone's not from the financial industry, and he or she wants to periodically get data with 60 hertz. I could imagine something like a sensor bleeping in the middle of the field, right? And you want to just get the data from that. So
keeping it monotonic is very hard.
Right. Okay.
So this is the guarantee of giving 16 hertz without losing the guarantee. We can achieve 3,200 clients with only 4 core. This is the prototype result. Prototype class result. Which is my point is achieving this with Rust is not that hard, with C#, I need to take about 2 months.
Yes.
Well, I'm proficient with C# and it took me 2 months to develop code like this. With Rust, only 9 days.
Wow. Okay.
Next one is matching engine.
Okay.
This is our core.
Right. Yeah. So there's a question from David. If you see the chat, can you explain the concept of frequency in the setting? So what's 60 hertz? Could you explain what 60 hertz is?
60 hertz is giving 60 messages per second.
Okay.
With a monotone tick, tick.
Constant tick.
Constant tick.
I like a constant tick. Okay.
Constant tick. It's really hard,
Yeah.
Really hard.
Okay, no problem, David.
Yeah. And apparently we can achieve it with Actor framework, which is Actix in Rust.
Wow.
Framework.
Okay. Yeah.
And actually, I cannot see David's chat here.
Oh, you can't see David's chat here?
While I'm presenting, I cannot see.
I think, David. Oh, of course, yeah. course. Yeah.
This won't take long. Only
Sure.
3 slide left, maybe.
Yeah. Don't rush, man. Like the point is to go through the presentation and just talk and not rushing through it.
And hopefully we can discuss it because
exactly.
I need the audience to understand.
Exactly. Yeah. That thing too.
Okay. And this last one, which is the matching engine, because the code is not in public, I will share to you live, so you can see what's inside our core. So one disclaimer is this code, I made only 3 days with this code, 3 days, but the performance is quite staggering for me, even for me. So with 10,000 order, 5,000 perfect limit match, it took only 5 million nanoseconds, which is which is 1.8 million orders per second, which is not bad for prototype class. Yeah,
that's amazing for a prototype class. That's actually amazing. Yeah.
And with 5 million orders, 10 million orders, apparently the performance dropped to 5,000 orders per second. And this was not tested in live server, only from my laptop, which is, I think, quite good. Because not server code, not server tested. Yeah.
Okay.
And apparently the presentation is finished. Now I should share the code, but before that, if anyone want to ask, just please ask, or maybe go back. Yeah, please open your microphone because I cannot see the chat.
Yeah. Yeah, exactly. So yeah, feel free.
Yep. Something maybe.
Hello.
Yes. Is someone talking or what?
Nope.
Okay. I have the question was, which tool do you use to benchmark or to draw those graphs?
Well, because this is 3 days code, I only use the code itself to benchmark itself, and the second one is I use Valgrind to see catch misses. Catch misses something. Yeah. So the actual code is, I call it a CC matching engine because initially I want to create cache coherent matching engine. That's the idea, but yeah. Almost
cache coherent matching engine. Now I realize the CC in front of the CC means cache coherent. Okay.
Yeah. Yes, and I design all the struct with as small as possible to fit the LC cache and L1 cache.
Okay.
Yeah. David, maybe?
Hello.
Oh, Mr. Budiman, okay.
Yeah.
Okay.
I have a question.
Okay.
Can you explain deeper about what you mean by reactive? And is the actor model you mentioned is the same as the one in Akka framework?
Yes, really close with Akka framework. Exactly. Really close with Akka framework. And the reactive means, we can say polling, but not, polling is not the case for WebSocket because the communication channel is bidirectional and the message is asynchronous. So I call it reactive. When the message came to the system and the system answered it asynchronously, so I call it reactive. Only that's maybe the term is wrong. What do you think?
Okay. I don't know.
Okay, no worries. David, did you want to talk earlier?
No, it's okay. Just following.
Okay.
Thanks.
Okay, I think I better show my code. Unless Nenen, maybe?
I might have a quick question, pretty basic.
Yep.
On the first slide, you mentioned 5 hypotheses about the behavior of Rust. Were these statements or questions that you wanted to actually confirm and verify?
Yeah, actually, yeah, but maybe not all. Concurrency, I'm not going to show about concurrency because it's already demonstrated in the WebSocket code. But in matching engine, in the current matching engine, no concurrency, no multi-threading.
I see.
So yeah, I'm going to show even coding from scratch, from nothing, just to show you how easy it is with Rust.
Okay, so these
overall,
buzzwords, these buzzwords.
Yeah, overall, when you say buzzword, you're actually confirming these, right? Or
yes,
or
it did.
some
Yes,
of
it did.
So all of these mean that Rust has all of these characteristics, right? So zero cost abstractions, memory safety, concurrency. What do you mean by fearless concurrency? Do you mean by it's actually?
When I create a concurrent code, when the compiler says, "Okay, your code is good," I have no fear. That's all.
Also, what do you mean by that is that you're not afraid that the program crashes or segfaults.
Okay.
Is that correct? Is that correct?
Yeah, actually, yeah. But what I meant is when I code a concurrent code, like for example, for the WebSocket code. Okay. When the compiler says, "Okay, your code is good,"
it means it's absolutely good.
It's actually good. I mean, there will be no unsafe mutation of some data.
Amazing. Okay.
It's kind of impossible unless you're using unsafe code. So be careful. That's all. And then fast and not hard. I think I'm going to show you at least 3 of these buzzwords, since this presentation is about Bitwire's journey into Rust, into low latency with Rust. So I'm going to show I'm going to show you about memory safety, friendly neighbor compiler, and the fast. Well, not the fastest, because C++ is never going to be beaten by Rust. That's my opinion. And also these challenges I'm going to show you.
So overall, when you started looking into this a couple months ago, it was pretty much an open question. Do you think it's been valuable? Do you think, do you think it actually makes sense to use part of the platform to be written in Rust? Are there benefits overall? Or would it have been just as good to continue in C? Or C++?
I really think that Rust is very good for our early deliverable, because coding with Rust is not so bad, not so hard. And now I can code some microservices in 5 days, 3 days, 2 days, which is not possible with C#, and can only possible with Python, but the Python code is kind of slow and not good for our case. So I think for the first deliverable, we can do Rust, and when we have time to mature it, we will port it to C++, or even FPGA, because we need to achieve very, very, very fast code.
Right, but does it not seem to be a great compromise between the fast prototyping of Python and the capacity and the computational performance of C? Doesn't seem like a great compromise? And do you not think that in the long run, if things are improved on the performance of Rust, maybe it'll actually catch up and be beneficial to continue with that?
Well, actually, you have a point there, but some code, uh, like, okay, I'm going to show you the challenge. Sorry. The binary size is problematic in Rust. So good performance code lives on L1 cache, instruction L1 cache. So it's hard to do that in Rust. I'm going to show you the Valgrind test after this. It will have a lot of catch misses.
Is it equally difficult in C++? Like you can only do this in C?
Not really. Actually, there's a lot of operations in that are in C++ that's easier to do it in C++ rather than doing it in C, right?
That's right. That's right.
Yeah.
But
also in Rust, I believe.
Yeah, like for example, this matching engine code, which I'm going to show you later after this presentation.
The simplest one is like std vector. I'm sorry to interrupt. Go ahead.
Yep. std vector.
Yeah, it's a hardest.
std vector, linked list. Linked list is
maybe right.
easy. Yeah.
Yeah.
But hash map, like Google hash map, Swiss table hash map.
Yeah, it's hard.
Bitwyre map is very hard if we code it in C.
Yeah.
Well,
yeah.
I think this code
maybe hard is not the right word. Maybe like tedious is the right word, because like you need to do mallocs all over the place and
exhaustive.
It's exhaustive compared to like in C++ where you could like literally it's like a couple of lines for a lot of lines in C, something like that. Yeah, and
well,
go ahead.
Well, we do a lot of research since I'm the research chief, and I think when Bitwyre are already running, and then we have time to do a lot of research with, this is the first 2 months journey with Rust, and already amazing for me. So Rust is good for now. That's
and why, as a junior programmer, I doesn't have reason to use Rust. Nanan asked that, so
I see.
Yeah, I don't have a reason. So okay, so could you explain a little bit why you don't want to use Rust, or like there's no reason to use Rust? Why is it? Maybe he or she.
Thank you for reading the chat. I
know
read it.
Sometimes I try new language. Okay, yeah. So yeah, maybe you try new, like, okay, compared to like Python or like C++ or like Rust. I believe David has a point before mentioning that you can like do fast prototyping, but I don't actually agree that the fast prototyping is better than Rust rather than C++. I actually don't agree with that. Maybe someone else.
Well, actually, it took me 9 years as a programmer to actually do 3 days of matching engine.
Right.
But transitioning from C# to Rust is not so hard. So I think my advice to junior programmer is learn Python code, so we can focus on good algo, and then do Rust. So Rust is a young language. Maybe only hundreds of thousands programmers of Rust programmer in the world, but a lot of them are young. Steve Klapnik is very young, and in the contrary, C++ programmer is kind of geeky, Maybe that's wrong for Dendi school.
Song King, I think Song King is the
and Song King is very young, yeah.
Yeah.
You two are magical.
I think the reason why as a junior programmer we should do C++ is the recent development of the language has been I think the standard committee realized that onboarding people to C++ was a hard problem before, because you need to learn a lot of the hard semantics of the language itself. I don't know if you agree with me, Sonken, but I realized that to write C++, you need to understand CMake, and which is the build system, which also you need to understand the include headers, and then you need to understand prints and see out.
Yeah,
right? So
that's
like,
true. That's true.
Why do you need to like pipe things and like see it as streams and what's the difference between string stream and string view, and it's all these problems.
It's really headache,
It's a headache, like, and I believe when you're a junior program, all you want to do is your program to run, right? And you learn the algos behind it. But yeah.
Also, I remember 2 months ago, I said to Dandy, I'm avoiding Python for prototyping. I really like C#.
I was like looking at
that's
crazy.
And then that's not the case anymore. I think I'm going to prototype anything in Rust. So
it's even crazier.
I will show you why.
Go ahead. Please
okay.
do.
So I'm going to stop this presentation for now, and then I'm going to share the screen, the whole screen. Okay. Wow, 11 chat. Just wait. Okay. Share entire desktop. So you guys can see my screen, right?
Wow, a geek screen.
Geek screen. Okay, thank you. Okay, first of all, I'm going to show you nothing. CD repo, CD personal, CD RAS. I'm creating a directory, like RS hello world. CD as hello world. Then cargo initialize and cargo run. Done. Hello world. Magic, right?
Wow.
You can't do that with C++, man.
Yeah, it's something that I remember there was a presentation by Matt Godbolt, I think, like at Chicago, and someone asked him like, well, Rust has cargo and stuff like that. What does C++ has? And like he couldn't answer the question, and yeah, as a C++ programmer, I believe you too, Sonken, like seeing cargo and how to do just that is just amazing. It's
wow. Yeah, it's really amazing.
Really fast, really fast.
Are you moving to Rust, Sonken?
I'm already thinking of learning, and like I'm currently learning.
No, only cargo is not a sufficient reason to move from the powerful language.
Okay.
I see.
Just a joke anyway. Okay, I'm going to show you. I'm going to pin this and how hard it is to code. Okay. I'm going to insert something here like. Okay. No, it's hard. It's really hard in Vim. My name is Kresna. That's all.
You had a mistake.
Yeah. See, I want to show you how noisy the name were. This is the error.
Okay.
Unterminated double quote string.
Yeah, that's amazing.
And aborting to previous error could not compile blah blah. But look at the error, man.
It's really beautiful. Yeah.
Yeah. I want to show you this. And then I'm using Visual Studio Code. Sorry, Danny.
It's he's Vim, man. Vim is beautiful.
Yeah. Okay. So Visual Studio Code will show you the same error. And then I'm going to run. Sorry, not cargo run. So, and yeah, how easy it is. And okay, so cargo also help you install dependencies like cargo add Saturday. I think cargo edit. No. Cargo add.
Oh, you can do cargo add.
Yep, Saturday.
Oh. Okay.
And then Saturday is here.
I didn't know you could do that. I thought you could only write it manually.
Yeah.
Okay.
I never told Andy. Yeah, I never told him.
Okay.
And let's say I have, well, dependency nightmare. So I don't know which version good. So I think I'm going to cargo update, cargo upgrade. See, the version
amazing.
So then also with the current code, this is the matching engine code. And I'm going to show you cargo 3. Please show me duplicates. Nothing, no duplicates. And then I'm going to show you WebSocket core codes, which has dependency nightmare. Repo, Bitwyre, old Bitwyre, WebSocket core. Oops. Okay. This code will not compile it. I'm not mistaken. Cargo 3. Yeah. So here we go. It show you dependency nightmare. These all are the duplicates of dependencies. This is quite problematic because if you see the size of the build code, sorry, I think I'm going to cargo build. Oh wait, CD target.
It won't take time to build it.
Yeah, you're right. Oh, nothing here. Cargo build. 300 crates. Since this is not a release code, it's faster build. Please wait.
I like waiting for builds. It's okay.
Yeah.
I don't know about you, Song Kang.
And there is no build system, so you just run cargo like that and you are okay.
Yeah.
Yeah.
You are right.
Wow.
Yeah, that's pretty amazing, I guess. Yeah.
Yes, but you have your dependencies just like the node module folder. Do you know the node module folder?
Yeah, the node modules.
Yeah.
Okay. Fox, hello Fox, how's it going? So Fox just joined us.
Oh, Fox. Hello, Fox.
Hello, Fox.
Fox.
So
Fox
we're
Domestican, yeah.
Hello, Fox Domestican. How are you?
Cool. Very cool.
So we're maybe okay. Song Kang raised his hand. Were you about to say something?
I'm just testing in production.
trying out things. So yeah, for those who just like joined a little bit about us, we're a small group. This conference is sponsored by Bitwyre, although anyone else is free to sponsor it. Right now, our Bitwyre Chief of Research and Development is presenting the code on WebSockets. And I believe he just compiled his Rust code. So that's what you just saw on your screen right now. And yeah.
They practically built everything.
Oh, wow.
Times, yeah. I was talking but muted. Funny.
Sorry. My bad. No. Go ahead. Do you want to say something? Go ahead.
No. I was just talking a lot of things but muted.
I see.
idiots. Idiot of me.
It happens sometimes in Zoom, man. Like,
Yeah.
with these conferences. It's like,
Krishna.
Yeah.
Did you really need all those dependencies or what?
Okay, I'm going to show after build. After this build, what was I really need? I don't need all this dependency, but apparently the dependency needs it.
oh, that's weird because in C++ I remember using CMake and you could use, no, you don't use submodules. What you do is you could use submodules and in CMake you define a subdirectory, right? So add subdirectory, right? And then you'll build, CMake will build that subdirectory. All you need to do is have a CMake in each subdirectory and that's it.
Yeah, that's right. Okay, I'm going to show you the build size.
Okay.
Target, debug. Okay, the build size for a library is pretty big.
Okay,
okay, so
okay.
kind of hate it. Really. And now I'm going to show you the dependency. Cargo.toml.
Right.
So I only need this.
Oh, you only need that one.
Yes, apparently, but apparently the dependency. So yeah, we call it dependencies nightmare.
Oh, so it depends. So okay. What is the dev dependencies related to?
Oh, dev dependency only built for development only.
For development, okay.
Yeah. Like I remember Fahmi added something. Oh, CD example.
All right, David. Sweet. Thanks for joining, man. By the way.
Thanks for joining, David. Okay.
Yeah, I'll be right back. Thanks, guys.
Sweet.
Okay.
Very interesting, Kresna.
Yeah. Too bad you cannot see the matching engine code. I will show you later.
It's just that I have to step out, but I'll be back as fast as possible.
Cool. Thank you. Okay. So these files is the development only files. It will not go into the release image. So that's, I think this is about the performance, prototyping performance, right? So this is my matching engine code. I wrote this 3 days ago. Okay.
Nice.
The first commit was Sunday, but actually I code this 3 days ago, Thursday.
Nice.
And then, okay. And then I'm going to show you the code. Wait. I'm going to close all of this. And then, like this. Right, okay. Going to close all of it. First, I'm going to show you why this code is very fast, although it's prototype code. So I create this first before anything else, before the main program, before this 1,300 codes. I wrote this first. So before anything else, I declare the type. This type actually another type, so I alias the type. Like order ID is actually a universal unique ID. Yeah. Order volume is actually unassigned integer of 64-bit. Order price or code and UTC nanosecond. Why? Because first I want the other can read my code. So as you can see here, order event is UTC nanoseconds. The type is the type of event is an enumeration of this order event type, and remaining volume is optionally order volume, because actually you can make an order without the a volume. And then threaded price, optionally thread price, and cross ID, etc. This is even struct events of an order. And then we have order message. So matching engine is matching orders, right? So a lot of orders came in, a lot of orders hanging in the order book, and then it does the matching between orders. So this one is a message from the outside of this service, as a message. This is the details of it. And then I created another one, which is order book order. This special struct is only 24 bytes. Originally, I named the program as CC Matching Engine because I want this program to be cache coherent. So I created everything as small as possible. And then I implement, this is the abstraction, this is the zero cost abstraction I've mentioned earlier. This is how we attach a function, a method, to a struct as an object. Like in C# and Java, this is called interface. And in Rust, we call it trait. And then I implemented some partial equivalent trait for comparing between order size using memory discriminant. And well, this is quite easy. This part only took me about 2 hours, not that hard. So then I created this one, which took me about 1 day and a half, which is quite complex. I think I'm not going to present all of this to you.
But why? But like maybe explain like what it does on a greater scale.
Okay. Yeah. First of all, I'm going to hide all the details.
Nice. Okay.
Because we don't want to be cluttered. Okay. This file has two main objects, main structure. First one is order book, which contains the orders, and the type is a binary tree map, B-tree map. It contains the price level and orders of those price levels. And then the order location, which is a hash map or dictionary in Java and C#. The key is unsigned integer and price level. So this is a lookup table whenever we want to remove some order.
Okay.
And then the order books. So then they created earlier, this name is site order book, and this one is order book, right?
Right, that's correct.
So this order book has two sides, which the first one is bit side, yeah, and the second one is ask side. Ask means cells, bits mean bytes, and it has also order location. So whenever the system wants to remove some order, this is the lookup table. So we know which the order reside in which order book. That's all. It's pretty simple, and the size is pretty small. It's about 276 bytes. If we run this code, I think you're going to see this. First, am I too noisy?
No. You're good.
Okay. I've attached 3 methods for the order book, and this is how I did it. First method is count methods to count how many orders in the order book. And the second one is the removal of codes. So I can easily remove an order. It has new parameter. It's called is cancellation parameter. Because when this is not a cancellation order, we can just remove the first
one.
First, because vector in Rust is actually a FIFO buffer, first in, first out, and everything is in order according to added positioning. So everything, if I push something to the vector, it will come to the end of the vector. So it's an order, time order collection. So if I do cancellation, then the system is seeking the index of the order. So
it looks at the index.
Which is quite slow, because this is not a lookup, but it's an iteration lookup. It's an iteration lookup.
It takes ON, I believe. Yeah.
Yes,
so
ON. Exactly. So this is slower. When we cancel an order, is slow. But if we remove an order because the order has matched, it's fast. Okay.
That's hilarious.
Okay, and the last method is insertion. Yeah. If we're going to insert an order into an order book, the caller must specify the price level and then the order book order object itself. So in Rust, if we pass things like this, it becomes the ownership of this object is
the ownership moves.
So by default it moves unless the object has a copy trait. So
unless the object has a copy trait. So you define the copy trait first, then
here.
When you
I can define it here.
So you derive it based on that. So you derive clone, you derive copy, and now I understand your code. I was about to
pretty easy, right? When you understand it, it's like, man, this is easy.
It's really quite like CPP, but there's no ifs, and then you need to do matches, and then you derive it like this. So cool.
Yeah. Well, Rust is gaining advantage of C++ modern, I think.
Yeah.
I think
or both.
Rust, some Rust internal team always coming to the
CPPCon and some and the other way around.
Yeah, I think so too. Yeah. So yeah, unless the object is has a copy trait. So wait, okay. So this semantic like this, it will transfer the order book. It will move the order book from the caller to the method. So actually, the order book is transferred to the orders. So this is pretty efficient, I think. And then implement default for order book. This is for order book creation. Actually, I create I instantiate the order book like this, pretty easy. And order books is also pretty easy because the order book has a default trait. Then that's it. So yeah. And then first, I'm going to show this crazy codes, really complex. Really complex code. Before I think I'm going to show you the unit test. And the unit test it's embedded in the module. It's like catch 2 in C++, right?
Catch 2, yeah. We use catch 2. Yeah.
It's like catch 2. And this code will not get filled when I said cargo build, cargo build release, it will not get built because I specified only build this module, only build this unit test module for tests. So this module will not get built. And then, okay, I'm going to show you the unit test. This current implementation has 19 unit tests, so many. And I'm not going to show you all, only show you one, like this, under test. Okay, the test passed.
Nice.
What really fun with Visual Studio Code and for us is I can click the test here.
Oh, you could do that? I did not know that. That's crazy.
Visual Studio Code, didn't you?
No, not yet. I'm still in Vim, man. I'm still in Vim.
Okay. Okay. So for running all the tests, I can just cargo tests. Okay. All okay. See, yeah. Well, I meant if I made something wrong here, like one cargo test will fail. It's a fail because the left side says 0 and you are expecting 1.
1. Oh, so it shows the left, right.
The line.
Okay.
And with Visual Studio Code, I can just click it here.
Oh my God. Okay.
Are you thinking about moving to Visual Studio Code?
Yeah, so someone like really like made it more worse than you. Like he said to me that, hey man, like your Vim setup is like a heroin junkie setup. Maybe I should move to somewhere else. But like if I'm moving, I'm moving to C Lion, man. I'm not moving to.
Okay, C Lion is cool for C++.
Yeah.
Not for C. I could C with Visual Studio Code too. sorry.
No, it's fine.
Not relevant.
It's fine. There's fun in these things, right?
Yeah,
it's
really
fun. Really fun.
Yeah. So yeah, in pretty easy in the test in Rust. I think I'm not going to dwell a lot in the code. So, and then I'm going to show you the really complex code. So first of all, I'm going to unset this.
Okay.
I'm going to remove this. And let's see what is the result method. Article. Oh wait. Brooklyn is pretty hard stuff. I think it's okay. Cargo Clippy.
What does Clippy do? Like,
Clippy is like linter.
Oh, well, isn't it FMT? What is it? Isn't it?
FMT is the formatter like Python Black.
Oh, like Python Black. Okay.
Yes, actually, Cargo FMT is coupled with Cargo Clippy.
Clippy, I see.
Because Cargo FMT is taking recommendation from Cargo Clippy.
Okay.
So, see the compiler complaining. The function has a cognitive complexity of 45, and the limit is 25. It complaining me. Yeah,
it's crazy.
Complains. And the help code is the help message is you should split it up into multiple smaller functions.
Oh.
Good advice. Good advice. Yeah.
That's like code complexity.
This is the friendly neighbor. I've been telling you.
Right.
Yeah. So I'm going to undo.
Yeah. Matching engine code has always been hard to discern. I mean, there's also, if you're using Rust, you're using matches all over the place. And in C++ or Python, you use ifs. And like you need to check the sides, and that's probably you just cannot do it without it.
Yeah, a lot of if, maybe a lot of switch case in C++, maybe.
Right, switch cases.
Okay, now, okay, should I show you this complex code? Okay, that's a yes. Okay. First of all,
actually, it's fine.
Okay.
If you know, maybe
also,
you could see the benchmarks if you want to skip.
Okay.
Yeah.
I think I'm going to explain this really fast.
Sure.
Brief explanation.
Sure.
The order books also have a count method.
That's correct.
Which is calling the bits, the order book count, and yeah, this one, and also aggregates the value. So this is a tuple. The first tuple is the bit order book count, and the second one is the ask count, and the last one is the sum. And then removal also has a is cancellation flag, which is a boolean. If this order is a cancellation, it will take longer than the match or than the match removal.
Oh, so you're actually splitting between removes, that's removing from the order book, or cancellation.
Yes.
Okay.
And this could be dangerous if we don't have unit tests, but actually the unit tests prevent I made something wrong with the code. That's what's good. What's good with TDD. Yeah, but that's another aspect. Yeah, and then the insertion also quite simple actually. It checks if the order book has order location has the
contains a
key. Yeah. If yes, it panics.
Okay.
It tells you that the system is wrong because good system should not allow the same order cut into the matching engine
twice. Right.
Yeah, twice or more. Then it checks the types. If it's a cancellation.
Okay.
Also panic because it's
You're not
should
allowed
not be
to.
inserted.
Okay.
Yeah. Also, I have to mention that it has the R sharp prefix.
Yeah. So there was a question by one of our audiences, Nenin, I think, or Andre. So
yep.
He or she was asking what's like R sharp? Why is it allowed in sharp in Rust?
Okay. This is actually not R sharp. It's a type, actually.
It's a type.
Type is a keyword in Rust.
Okay.
Type is a keyword like this. Type something.
Oh, so
I'm not allowed to do names some member of a struct like this. This is not permitted. This is forbidden. So Rust was telling me, the compiler was telling me to add R sharp. So yeah, when something when the keyword collides with our code, we could add R sharp. I don't know what it means actually. But,
okay.
Yeah. And then this is the match. And it's been yeah. This is the match. If the order side is bit side, then it goes to the the order book is the bits. I have to mention this is a reference, mutable reference of the bit.
Mutable reference. So that symbol is a mutable reference of that. Okay.
Yep. And for access, if no side, attempt to insert cancel order, and it will print the order ID.
Okay.
But apparently the program crashed. So before this service should be there should be sanity check. So then the order book order, I create a new order book order which is only for the order book, which contains only two members. For the first one is the ID, and then the remaining volume. No price or whatsoever. No user ID, no bloated data. Only these two essential data. And then the order price got from the order message, and this become the key for order book insertion. Order book insert, order price, new order book order, and then I should not forget to add it to the order's location.
Okay.
Which is the side of the order. Okay,
Nice.
and then execute order. This function, this one function is 45 cognitive complexity. Yeah, this is very complex. It's a fair warning. So this is the frame of the code, the shell of the code.
So you basically set like current order ID or the properties of the orders, and then you so you only for C++ you switch between the current order type, and then you
matching, right?
Multiple,
yeah.
If it's cancel, if it's market, if it's like,
that's right. Before that, this is important. So this execute order function is given immutable reference of an order message. So
immutable reference.
Immutable. So it means that the caller has a guarantee that the message
is not changed.
It will not be changed. And then I copy all of the details of the message needed for the execution into this variable. It's someone talking?
Not me.
No?
Moi et Eric pour un projet de plateforme de streaming de
David.
Okay.
I muted him. Sorry.
Oh yeah, okay. Why did I copy the value? Because the order message lies in the heap. The heap is very slow.
Okay. So
the heap is very slow. So I move it into the stack.
So it's fast.
Even better, if this function can fit into the L1 cache of instructions, it will live in the register really fast. I know this because earlier this year I made some code for seismic data processing, and and because of that I understand this.
Okay.
And then
so that size, so the size of that code is around a couple of kilobytes, right?
270 kilobytes
for that function, only for that function.
No. For all of the function, including the library.
Right.
I think I will. Wait, I cannot do that.
So
I was thinking Matt Godbolt.
Right, compiler explorer, right?
But I think I tried that 2 days ago and
didn't work.
With no success. Yeah.
Okay. So I have a question. Maybe.
Okay.
So So the only reason I see why you want to copy the properties of an order message in an order book or like a matching engine is that you're using a lot of, for example, the price and volume quantities.
Yes, because I use this
extensively.
Often, and I'm avoiding
you don't want to
access.
change. I see. You don't. So if you're using heap memory access, it's possible that you change or you may mutate the type or mutate the data. No, not really.
It's not about mutability.
It's about speed.
It's about speed. Only because of speed. Only that.
Okay.
Remember, I said Rust is very safe. If I didn't mention mute like this, mutable like this, it will not be.
It will not run. Okay.
It's a guarantee. The compiler will prevent me to, like, for example.
You have a two. Oh, okay, before. Okay.
Cannot assign to order message ID because which is behind reference.
Reference.
Yeah, it cannot be written. So
okay. Noted.
If I specify this,
then it's fine.
It's building. It's building.
Oh, it takes time.
Yeah. CC matching engine, blah blah blah, and as you can see.
I see.
That's all.
Nice, nice, nice.
So this is only about speed. Okay, and then the truth of the matching engine.
Okay.
It splits for three kind of order. So cancellation order is also an order here in this code. An order of cancel, market, and limit. So this is the code of cancellation. Blah blah blah. It's boring. And then this is the code for market, which is already complex. The most complex part is the market order, and then limit order. No, I don't think I'm going to explain about this. Well, in summary, this code is we'll do matching between the market order types and limit order types. If no match, it will come to the order book. It will go inside the order book. The insertion like this. And this is the events produced by the matching sequences. And then it will be used for another services like Kafka for trade aggregator, for database, for transaction log, anything. But this matching engine only produces those events, while the order message itself is immutable. That's all. So the last part is I think I'm going to show you how this code
runs.
Performance of this code.
Amazing.
Okay. I think I'm going to just do this.
Run sh. Boom.
Run. It will build first. Chrono. And do testing first to ensure that.
So cargo run actually like does a test. Okay.
No, it's actually not. It's run script. I made it. Yeah. This is the run script.
I remember the run script now. Okay.
Yep. This is the run script.
Okay. You have a backtrace and you do cargo test, then you have a Rust flags. Okay. Yeah, it's amazing.
And also has ball green.
Oh, automatic pseudo ball green.
Yeah, but I comment it out because it's slow.
Right.
I will show you after this test. So I think one Australian exchange, if I'm not mistaken, claiming that their exchange is the fastest. I think.
Okay.
I mean, not crypto exchange, but only an exchange.
Equity exchange. Okay.
Yeah, equity exchange. Yeah, and they say they are one of the fastest high frequency trading exchanges, and their number is 500,000 per second.
500.
And 500,000 orders per second.
Okay.
And we managed to
to
surpass that number only for
quickly.
3 days. That's my point.
That's amazing. It's that's really good.
Thank you. But as you can see, it's 1.5 million orders per second for 10,000 orders.
For 10,000.
And it slows down to 439 orders
per second.
39,000 orders
for limit.
Okay. For 10 million orders, which is very rare.
Yeah. So around like a million orders would be the normal ones, right?
Million orders. Okay, this one is million orders.
Yeah, that would be.
It's about 900,000 orders. Which is quite good for me. Okay, this is the task I made the task like this, the main code itself only 138 lines. Uh, if someone wants to see our code, is that possible, then some part of it?
Sure, of course, man.
Okay.
Let's feel free, man. Yeah.
Okay. Yeah. And then I created a macro to show the size of the structs, which is shown here when we start. CC matching engine Rust, blah blah blah. Data structure alignment. Order event size is 64 bytes. Order message is 120 bytes. Order book order is only 24 bytes, which is, I think we can decrease this unless we cannot decrease this into smaller one unless we're not using unique UUID, universal unique identifier. If we're not using that, this size can be smaller. And then the order book only 80 bytes. Order books only 200 bytes. And then thread management, it sets the thread to real time. So why real time? Because this is to prevent the kernel scheduler to evict the process when it somehow hangs. Like, okay, this is the code for setting, yeah. And if Dandy notice this, I don't use the normal print line.
Yeah. Using the
Because
libc print line.
because I'm not using
Standard
the standard library of Rust.
Okay.
I'm trying to remove all the bloated code, so it could be smaller. And then the size of the program is now 256 kilobytes.
It's crazy.
Yeah, but still big. The goal was to make it to 30
like
kilobytes.
32 okay.
Yeah.
Within
I
the
can.
cache.
Yeah, I think with C++ we can do that. That's my point.
Yeah.
We can do that with C++. And then, so yeah, this is where Rust code is defeated.
Yeah.
Yeah.
But like I could see with all the trouble that we're doing in C++ and trying to make it really small and fast, the ability to be safe is just guaranteed in Rust, that you actually, like, you don't mind in the beginning to just like have a lot more slower code rather than like buggy, you know what I mean?
Yeah, I know.
Yeah. So
buggy is problematic if we pass the code into production, then customers' money is,
it's a nightmare. It's a nightmare.
Yeah. And then our business is, I don't want to say about that, but
exactly.
I'm avoiding to eat some shoes.
Exactly.
Like, I think Songking has know the context of eating shoes.
Yeah, it's an internal joke.
Yeah, internal joke. I think originally came from Aditya Suseno.
I think he's here, right?
He's here. Makan sepatu, right?
Makan sepatu, yeah.
Yeah, and this is the benchmark code, which is pretty small, only 60 lines. Yeah, I can see it later.
That's crazy.
And then I forgot what I'm going to show you. Oh, the Valgrind. Okay. First of all, before I show you Valgrind, I'm going to remove this because it will take really long time to run. Okay. Then I'm going to do this run. Sorry.
Go ahead.
Yeah. I'm going to show you how coherent is this code to the processor, to the cache. Now it's finished.
Wow.
And then
oh, so now you have all these L2 cache misses, L1, L2 cache misses.
Apparently no L2 because Valgrind only check L1 and L3.
L1, L3. What?
LL.
Why?
LL is
Why?
L3.
Okay.
The last level.
Oh.
Valgrind only check the first and the last one.
Wow. Oh yeah.
As you can see here, I have 0.01%
Cache
instruction miss.
Okay.
And 0% last cache instruction miss.
So okay.
Yeah, this is the point of the name, the CC missing engine, and then the data misses is quite higher because it's really hard, man. And then one misses, yeah, it's 1% misses. I think it's not bad. And the last data miss rate, last cache miss rate is 0.3% because the data got spilled out. I mean, it's at some places it's still in the heap, like order message is still in the heap. So that's the miss. And yeah, that's all. I think I conclude my show unless anyone want to ask anything.
That's an amazing presentation, man. That's an amazing presentation. Really, and like the performance of the matching engine. Although I could, yeah, that's just amazing. Like it's fast.
Yeah.
It's
although some code may be not correct. Yeah.
It's not that it's not correct. I believe like there's some structure that, but like everything like in general is for like 3 days. It's just like you could literally put this in production, right? So with additional unit tests.
That's it. So the point of this presentation is to show you guys prototyping can be very, very powerful.
Very, very powerful.
Yeah, but sadly, it took me 1 month, exactly 1 month, to make peace with the borrow checker. That's a long story, but yeah, it took me 1 month to make peace with the compiler.
Make peace with the compiler.
Yeah, Rust compiler is very, very hard. It's like an arch enemy, but after 1 month, it becomes a friendly neighbor. Really, really helpful neighbor. Yeah, that's why.
Nice. That's yeah. I after like coding in Rust and comparing to like doing in C++, I realized the Rust compiler complains a lot. But
yeah, it is.
But I could think about like when I'm writing in C++, sometimes I have these segfaults, right? And I believe some can. I mean, I write very, very sloppy code sometimes in C++, and like I believe some can does not. And like I find out that I forget to dereference a pointer, or like even if I use unique pointer, like it's just.
You laugh.
Yeah, it's yeah. Whenever I like, okay, the program complies, it doesn't actually guarantee you that it complies with memory safety. So having that is pretty cool. At least if like I know recently like the C++ like lib I don't know if you have used libfuzzer or something. So a lot of people told me that using libfuzzer is actually something that's pretty nice to.
Pretty good for finding
bugs. Fuzz inputs such that you can find bug before exploits and stuff.
Yes, okay.
Yeah. Okay, so Kresna, thank you very much for the presentation.
Okay, thank you to you.
That's really cool. That's really cool. Maybe if how about Songking? Do you wanna present something, or do you feel like presenting the awesome fixed parser? Or?
Yeah, very awesome fixed parser.
Yeah.
I'm not sure I'm ready.
Okay.
It's okay.
Anytime.
Anytime. And
Anytime.
I think Songking is a brave heart.
Yeah.
He's very brave.
Yeah.
To dive into the fix code.
Yeah, to do the
Me
fix
and Danny
code.
avoiding it.
Yeah.
Me and Danny avoiding it. And Songking came. You're really amazing.
Okay, yeah, you're amazing. It's actually a challenge that no one would actually do, but you're doing it anyway, and like we realize that that's something that's really amazing with you, something. So that's really, really cool, man. Writing a fixed parser is just like it's a pain, and like from your explanation of like starting of headers like SOH and also like it's so basically it's basically an encoding scheme for messages, right? That's all. Right now there's better encoding schemes, but fix is one. But anyways,
really cool something.
Really cool something. Very cool. Very cool. Okay, guys. If so, maybe if something is okay to present it maybe next time, or like I'll present next time.
Cool.
Okay, we could probably wrap this up. Does anyone want to present basically right now,
or maybe ask anything? Yeah.
Or ask anything regarding to Kresna's presentation? That's great.
Maybe not related. Also okay.
Yeah, it's okay. It's fine. Yeah. Maybe anyone wants to join Bitwyre.
Danny.
I'm kidding.
Yeah.
But yeah, this hashtag promotion right there. But anyways,
next time maybe I'll present a better thing. So
no, that's actually
programmer can start. Yeah.
That
okay.
that's actually I think there was a program that asked like it's maybe too advanced for me, but that's okay. We're all learning new things here, and like maybe next time we should start. Yeah,
that's why I love Bitwyre. We're learning things like always.
On the fly. On the fly.
On the fly. While creating a company.
Yeah, while creating a company. Some people chastise me with that, but like so far that's not good. Anyways, guys. Okay.
Cool, Danny.
Thank you. It's very cool, Kresna, and also very, very, very cool work, something. Really, really cool. Anyways, okay, guys, we should. Anyways, a bit for you guys who are still here. We do this every month, and we're glad to have anyone present. So don't hesitate to reach me out, or also the other Bitwyre team members. We're actually wanting to make this a community, so more of a developer community, people who are interested in writing cryptographic code, maybe machine learning code, maybe just presenting about programming languages. To feel free to like present it here, and nothing's too bad to be presented. I believe everyone has
something to share.
Something to share, I believe. Okay. Well, I guess thank you for like joining our conference. We'll have this again by January, and I hope you enjoyed it.
Yeah, I hope you.
Yes.
Sweet.
Thank you, everyone. Thank you, everyone.
Thank you, everyone. Thank you, Song Kang. Thank you, Eric. Eric has joined.
Mr. Budiman.
Thank you, David. Thank you,
David.
Budiman. Thank you, Aditya. See you next month. See you next month. Bye bye.
See you guys next month. Bye bye.